Sharing large files across your local network shouldn't require uploading gigabytes of data to a cloud service just to download it on the computer sitting in the next room. Relying on an internet connection or third-party software adds unnecessary latency to the process. We are going to eliminate that bottleneck by building a fully functioning, secure FTP, or File Transfer Protocol, server, using the tools already included in Windows 10 or Windows Server. Before we start the configuration, there is one mandatory requirement. The computer acting as your host server must have a static IP address. If your router dynamically assigns a new IP address after a reboot, the network pathway will break, and your devices won't be able to find the server. By relying on native Windows protocols instead of external cloud services, your files never leave your local architecture. This ensures that your data remains on your own hardware and transfers at the full speed of your network cables. Step 1 is preparing a physical home for our data. On your host machine, navigate to a primary local drive and create a dedicated folder. Place a simple text file inside it now so we have a target to test later. To activate the FTP services, the path depends on your operating system. Windows 10 users will use the Turn Windows Features On or Off menu, while Windows Server users will operate through the Server Manager dashboard. If you are on Windows 10, expand the Internet Information Services section. Check the boxes for FTP Server, FTP Service, and Web Management Tools. On Windows Server, navigate to the Add Roles and Features wizard. Select the Web Server IIS role, and under Role Services, ensure both FTP Server and FTP Service are checked. Once your selections are made, click Install. The system takes a few moments to pull these components together and apply the changes. These tools are built into Windows by default, but are kept dormant. Enabling these features converts a standard operating system into a functional piece of network infrastructure. Now that the tools are active, open the Internet Information Services, or IIS, Manager. Expand your computer's name in the left pane. Right-click on Sites and select Add FTP Site. Enter a descriptive name for your server. Below that, point the physical path directly to the dedicated folder we created in Step 1. Next, select your machine's static IP and leave the port set to 21 to route incoming traffic. For an isolated network, select No SSL. Check Basic Authentication, which requires an explicit Windows username and password to access the directory. Under the Authorization section, allow access to specified users and check both read and write permissions. Click Finish and the site is officially created. This IIS configuration acts as a traffic controller. It monitors incoming requests and ensures that only traffic on the permitted network pathways can interact with the physical hard drive. To make the server accessible, we first need a dedicated local Windows user account and password specifically for your FTP connections. IIS settings alone do not fully protect your files. You must also configure OS-level NTFS security to ensure that only your designated FTP user has permission to open the folder. Right-click your host folder, select Properties, open the Security tab, and click the Advanced button. By default, permissions flow from parent drives to child folders. Clicking Disable Inheritance stops default users from accessing this directory. Add your new FTP user account and grant it full control, making it the only account with authority to manage this data. The folder is now secure, but the Windows Defender firewall will still block port 21 by default, preventing external devices from reaching the server. Open your firewall settings and select Allow an app or feature through Windows Defender Firewall. Find the FTP server entry and check both the private and public boxes. By combining IIS network rules, NTFS folder permissions, and explicit firewall exceptions, you ensure that your data is only accessible when a request passes all 3 security layers. Now we can test the connection. We'll leave the host server and move to a separate client computer connected to the same local network. Open a web browser and type ftp:// followed by your server's static IP address. Enter your credentials when prompted, and you will see the test file we created earlier. You can also type that address into the bar of Windows File Explorer. Once logged in, you can interact with the directory natively, dragging and dropping files as if they were on your local machine. For larger transfers, open an FTP client like FileZilla. Input the server's IP, your username, your password, in port 21, then hit Connect. Because FTP is a standardized protocol, your data is universally accessible across different types of software and operating systems. Your server is now fully operational. You have a functional local file server that operates independently of third-party cloud storage. Note the limitations of this current setup. These files are only accessible to devices on your local network. They cannot be reached from the outside internet yet. Moving beyond the local network requires a few more steps. Setting up router port forwarding and implementing SFTP or secure FTP encryption are the requirements for enabling safe remote access. Establishing this foundational FTP setup moves your data management to your own hardware. This is an essential first step toward building and managing your own custom, self-hosted network architecture.